Okay. I see there's more people still joining us, but it's already 1 o'clock, and I think the rest will join us soon. But I think for now we can basically start our meeting. I will try and share my screen. Okay, right. Okay, so unfortunately I don't have the option to share. But anyway, so hello and everyone, and thanks for joining us today for the South African Coal Processing Society technical meeting. Unfortunately, we are not able to meet face to face. However, we are, able to do it virtually in this space, and we're hoping that with everything that's happening, we might be able to meet each other very soon. And I guess we're glad that we are able to still share ideas in this virtual space. I think I would also like to just take this opportunity and offer my sincere condolences to everyone who's lost their loved ones as a result of the pandemic that we are faced with. And those who are still in recovery, I'm trusting for full recovery and them feeling better afterwards. And also, I think it's just a call to all of us who are now of the age between 35 and 50 to please register and go get vaccinated. The other thing that I would like to point out today is just for the registration of our conference this year. It's already open, and we will be hosting it in October, starting the 12th through to the 14th. The venue is still the same, the Graceland Hotel and Country Club in Secunda. If you need any maybe additional information also on how you can maybe have a stall or even help out, please visit the website or give Gerda a call. Also to note for the conference, it will also be face-to-face or virtual. So for those who are maybe concerned about attending around October, you can still register because there is the virtual conference that will be going on as well. Okay, so today we will have two presenters. And the title of the presentation is the Twin Mass Kinetic Energy System Application in the Coal Processing Sector. And our presenters will be Zaman Dlovu, as well as Leslie Charles Stoltenford. Zama is the CEO of Basadiba Africa, abbreviated BBA, Mining Solutions. She holds a BA honors in clinical psychology, and BBA is a wholly owned woman company. The company supplies twin mass energy saving vibratory equipment to the mining and quarrying industry. Equipment supplied includes vibrating grizzlies, feeders, as well as screens. Leslie Charles is a technical specialist and equipment designer for Lambeck Technology, LT, who are an OEM of vibratory equipment, both brute force and twin mass, including grizzlies, feeders, as well as screens. The company was started by Leslie Leslie Senior almost 40 years ago. All right, so before maybe we start with the presentations, I would like to just tell everyone who's online today with us, that you are able to ask questions. You can just type it on our chat, but at the end of the presentations, we will open up the floor to everyone who would like to ask a question. So for now, I'll hand over to Zama to give their presentation.
Thank you so much, Refilwe. Good afternoon, colleagues. I hope everyone is well and safe in these trying times of COVID. Thank you for the opportunity that you have granted us and our partner, which is Lambek Technologies. I'll quickly go through the background in terms of our partnership with Lambek Technologies and how Basadi works. We are obviously an all-women owned OEM of vibratory equipment, which is screens, feeders, and grizzlies. We established in 2016, and we are quite well in making inroads in the mining and quarrying industry. Our relationship with Lambek back in 2016, we were looking for opportunities in the mining sector, and they took us in, having experience of over 50 years in the space of manufacturing mining equipment. They took us in as mentees and together in every ventures that we get into. Our conversation will be very technical, so that's why there is Leslie with me, who is the head of a technical side of our company. And he is also a specialist from our mentee side, which is Lambek Technologies. And he will give you an outline of our technology and how it can be applied in coal treatment. Under the electricity shortages in current situations in South Africa, our technology is really leading. It can be 85% electricity reduction in real terms. So I'll hand over to Les, who go through the presentation, and then I will then take questions at the end of the presentation. Thank you. Okay, Les, you can proceed now.
Thank you very much, Zama. Good afternoon, everybody. Thank you for joining today, and thank you for the opportunity to present to you. Since we are talking innovation and technology, I'd like to start off just with a quick quote. Tom Friesen said once that innovation is taking two things that exist and putting them together. Why I believe this is important is because in our mining space, we have a lot of very good technologies, and I think it is important for us to sometimes step back and, instead of trying to reinvent the wheel, look at current technologies and how we can couple them together to further benefit our industry. In Eskom's 2019 brochure of mining, they said that electric motors account for 60% of the consumption in the industry. Over a lifespan, a motor can cost up to 100 times more than it did to buy. Why this is important is because South Africa and Africa is facing an energy crisis, which we believe we have the ability to solve with the right acceptance from the market. As Zama mentioned briefly, we have what we call the Kinetic or twin mass drive system, which has the ability to reduce power consumption with all process and equipment, whether it be vibrating feeders, vibrating screens, or grizzlies, by 60 to 90%. How it does this, and this is the technical background where we will discuss the difference between the traditional brute force system and the twin mass kinetic drive system. Traditional brute force equipment, which I'm sure most people in our industry or anybody who's been involved with plant processing will be quite familiar. The drive system has been powering vibratory equipment for decades. we look at the picture and the drawing on the bottom left-hand side, typically with brute force equipment, the motors are directly connected to the pan of the equipment. What this entails is that the motors are responsible for driving the entire mass of the unit as well as any applied load. This means that as the size of the screen is increased or the load is increased, the motors will inherently have to be larger. However, if we look at the right-hand side with the picture and the drawing, the kinetic drive system is different in that it uses two masses coupled with a system of drive springs. This means that the motors, which are connected to the first smaller mass, never see the mass of the pan or the applied load. Once the motors energize the first mass, the springs will then take over as they are power producing and will take over the motion to drive the second mass. This means that when the mass of the pan or the applied load is increased, the springs will then drive harder without any increase in power. Discussing some of the few advantages, and I will go into some of the technical details as to why these advantages are important and why they are applicable. Obviously, we have discussed the power advantage in that this equipment will reduce power by up to 90%. It does this because the motors only have to drive the first mass of the unit and never sees the mass of the pan or the applied load. The advantage of efficiency comes in that we know that in mining industry and material processing, material characteristics can have a real effect on your processing. So with the kinetic drive systems, because the drive springs are there to absorb any change in the flow of material, there is no drop in efficiency when material becomes more dense or heavier or lighter. The drive springs simply absorb any of the differences. When we are talking throughput, we are able to take feeders up to 1,000 tons per hour. We can do this because the motors are not responsible for driving that entire mass, but rather just the mass of the first mass, and then the springs each have a power producing effect to drive the rest of the mass. The cost implication of this is quite simple when we are talking about power and efficiency and throughput. These are the three main factors of any processing plant. So your cost of production is decreased and the efficiency is increased, and therefore your profits are higher. When we are talking lifespan of the equipment, with traditional brute force equipment, the motors are concentrated at one single point. This means that the forces at that point are incredibly high. This is what leads to torsional twisting and material fatigue. However, with the kinetic drive system, each of the motors, each of the drive springs absorbs a percentage of the power. That means that the force from the motors is distributed across the entire length of the pan, rather than concentrated at one point. Some of the other key advantages is lower maintenance cost, the ability to pulse or change the stroke, which will help in unblocking your pan. It will help with high moisture content. There's also the advantages where we are unrestricted in both length and width dimensions. The noise levels of the equipment is dropped. Maintenance costs are dropped. We are able to stop and start the equipment under load. And there is also the ability to put in a built-in underpan. What this means is that instead of having a screen with a steep valley hopper or bin underneath, you can have it on ground level with an underpan for your finer material. This is especially important when talking about new plants because it can drastically reduce the cost of setting up a plant. Go through a couple of case studies. This is a feeder we did for Anglo Gold. when Kopenhagen mine was still owned by Anglo Gold, and was designed to extract ore from the silo at 1,000 tons per hour. This 2 meter by 6 meter energy saving feeder was designed and manufactured and installed utilizing just two 3.5 kilowatt motors. The previous system was a conveyor belt, which honestly gave the mine endless problems. And that is why within the first month, the output was increased from 7,500 tons to 68,000 tons within the first month, and had the potential to increase to 120,000 tons. This reduced the operational cost by more than 250,000 Rand per month, and the load time to fill the 8 railcar hoppers was reduced from 14 hours, which included the average breakdowns and clearing of the belt, to under an hour. With traditional brute force vibratory feeders was not possible because of the need to stop and start the unit under load. Obviously, filling a rail hopper, it would have to fill a cart, stop, and then start again under load. Briefly, two of our most recent projects. On the left-hand side, we have a vibration feeder, which was installed at Pilanesberg Platinum. This unit is 1,500 wide by 8 meters long and runs off just 7.5 kilowatts. It takes feed of upwards of 600 millimeter run of mine directly from the dump trucks. It feeds at a rate of approximately 600 to 900 tons an hour. These units were installed back in 2010, and we replaced the first one in 2020. So those feeders, even though it's taken on such a large load at such intense tonnages, it still has a lifespan of 10 years. Our most recent project on the right-hand side is a double-deck screen that we did for Debswana Diamond. It's a primary screen that sits on Damsa Mine. The screen is 2.4 meters by 5.5 meters long and uses just two 2.3 kilowatt motors, so 4.6 kilowatts in total. The screen it replaced was a 36 kilowatt screen doing the exact operation, and that is an 87% power, 87% saving of power. The screen was designed to retrofit the exact footprint of the current screen, and therefore no structural modifications were required. The last case study I want to go through is a screen that we installed at a ceramic mine. Now, what makes this quite interesting is if you look at the picture on the bottom right-hand corner, is this screen is divided into two sections. It has a feeding section and a screening section. What this entails is that you now no longer have to use two separate pieces of equipment to do your primary feed-in and your primary screening or grizzling. This unit was 1.5 meters long, 1.5 meters wide by 5.5 meters, and used only 1.8 kilowatts, which is, two 1.8 kilowatt motors, a total of 3.6 kilowatts. As I mentioned earlier, you can see this unit has a built-in underpan, therefore there is no space underneath the screen needed for your undersize. This unit is fed directly into a small chute on top of it from a front-end loader. Material size varies from ultra fines to upwards of 600 millimeter lumps. This unit does a separation of 100 millimeters, and using a VSD, the capacity of the screen varies between 90 and 120 tons an hour, with the potential to increase up to 200 tons an hour. Play a short video. As you can see with the built-in underpan, The screen has the ability to sit directly on the floor, and your fines can be exited with a conveyor belt at ground level. When discussing the typical return of investment of a screen, there are a couple of factors we need to take into account. Average cost of a screen on most large mining companies is between 2 and 3 million rand. Each of these mining companies have approximately 8 to 16 primary screens per plant. The average consumption of a typical brute force screen is approximately 36 kilowatts, where the average power consumption of Kinetic screens is 5 kilowatts. As you can see at the bottom, we've done just a quick calculation, and this is quite important because if you have screens on your plant or operation, you can take this equation and just work out your savings for yourself. We have taken the typical kilowatts times by the hours per day, times by approximately 330 days per year, and you get an annual saving of 483,000 Rand per screen. So you can imagine if this was applied through 10 or 15 screens on a specific application. It has the potential to save South Africa not only millions of rands, but also a substantial amount of power. Thank you. That is all for myself. I don't know if Zama wants to say a couple of words. Otherwise, thank you very much for your time.
Thank you, Les. I think you've covered it all. We can take questions in whichever sequence that Refilwe will deem fit. I'm not sure how would you like us to do that?
Yeah, I think what we can do now, we can open the floor to take questions from our attendees. Again, if you need to type any questions as well, you are welcome to do so. Any questions from the floor? Okay, Henny Engelbrecht, I see your hand.
Thank you, Refilwe, and Zama, Leslie, thank you for the presentation. I would just like to hear you comment on penetration into the mining industry. I mean, with all of these savings, you know, when you started the presentation, I thought there was some magic in this technology, but because it's operating, it's not magic, it's technical. So I'd like to hear you comment about penetration into the mining industry, and then secondly, you know, opportunities to swap out, because typically some of the major plants have been designed around current equipment, and there's certain dimensional impacts. Have you had opportunities for swap outs with traditional brute force, and what factors played into your advantage in terms of being able to give your clients that benefit? Thank you.
Hi, Annie. Thank you very much for that question. Yeah, so the penetration within the mining industry has been reasonably slow. This technology has been around for well over a decade. But obviously with the energy crisis being more and more applicable, the penetration is getting better and better. We have done major projects with a lot of the large mining houses, being Exxaro, Anglo Gold Ashanti, Sibanye. So there is very good penetration, but it is expanding greatly by the day. With regards to the swap out, you're 100% correct. The most crucial thing that we need to do is be able to replace this equipment directly with a traditional brute force unit. That's why we do focus primarily on that. In the presentation, I did talk about the screen at Debswana, which was retrofitted. So we will fit and design this unit to match the exact screen that you would be taking out. Within the same dimensions, there are a couple of benefits. Obviously, you know, your width and material doesn't change, so there's a couple of constants there, but we do have the ability to fluctuate the stroke on these units. So if you are fit in the exact screen with a opposed of a traditional brute force screen, there are slight benefits in terms of efficiency and throughput, but obviously the power saving will be the main benefit. Thank you.
Okay. Thank you, Les Charles. A question from Maynard Lombard. There's two of them, but let me see if I can start. The first one, he's asking, is the screening efficiency affected? I don't know if he wants to elaborate a little bit more on that one. His second question is this screening technology only used for dry applications as per your case studies, or can it be used in wet screening applications?
Okay, thank you for that. Yes, so with regards to the wet screen applications, look, it has the same operational standards as a typical screen, so it can be applied with wet applications, dry applications. It doesn't really matter. It's just things we need to take into consideration when designing. In terms of the efficiency being affected, obviously, if we're replacing a screen, a traditional brute force screen with the exact same size traditional, or with the exact same size kinetic drive screen, there aren't huge benefits to the efficiency because the screens have been designed as they are. However, there is slight increases in efficiency. As I said, you can fluctuate the stroke on these units, so you would vary between, let's say, 6 millimeters to 12 millimeters strokes, which will stop your screen from getting blocked as much, or it will separate your material better. So if you're replacing a existing brute force unit, other than the power savings, up to 90% power savings, there will be a slight increase in efficiency. Thank you.
Thank you, Les Charles. Then we've got another one from Stefan Baxter. How far from resonance does the machine operate?
Hi, thanks for that question, Stefan. So the resonance would be quite important if your building or your current structure had a particular resonance. We do have, it is a consideration we do have to take into account with design, but those are in very specific instances. When you have a large building or a large structure with a number of different pieces of equipment supported by it, is when you start having problems with resonance. So if there is a particular structure which also houses your crusher or a mill or something like that, then it is very important for us to design and counteract the resonance. But if it is a typical coal plant where each screen is on pretty much its own structure, or it's sitting directly on the floor, whatever the case may be, the resonance is usually quite far from the structure. But yes, it is, if resonance is something that you have a concern with on your plant, or it is a problem you've had on your plant before, it is something we need to take into account and design for. Thank you.
Thank you. I don't see any more questions in the chat. If there's anyone around who needs to ask, Okay, Devraj, I see your hand.
Yeah, I just want to understand from a CapEx perspective, OpEx perspective, how does it compare to the traditional brute force screen? So total cost of ownership of this type of screen.
Sure, thank you very much. So the common misconception is that, you know, given all of the drive springs, that this equipment would tend to be more expensive. However, you know, with vibratory equipment, your motors make up at least 40% of the cost. So since we are dropping the size of the motors so much or so greatly, the cost of the equipment tends to stay around about the same. So with the bigger your units get, the cheaper the kinetic drive system becomes, because then we're moving away from 36, 40 kilowatt motors. But most of the units within the coal industry are slightly smaller than that. So with a typical brute force unit and a typical twin mass unit, the prices are almost identical. The smaller you go on the unit, the kinetic drive will become a little bit more expensive, and the larger you go on the unit, the cheaper the kinetic drive system will be. Thank you.
Alrighty. A question from Christian. Please give more information on the relationship between Basadiba Africa and Lambec. Who is the unit purchased from and who gives the technical support?
Okay, in terms of the relationship, it's more of a, okay, it's we work together because we still under the mentorship for now. Our relationship is in such that we are sharing designers and also sharing the manufacturing space. We're still incubated within Lambec, so we share the factory space with them. So if the unit is purchased within Lambec, it's done by the designers that are also mentoring us as Basadi. If it's purchased within Basadi, it's also done. We work as a team. In fact, we share the technical team, which is why Les is doing this technical presentation today. So we're more like a child to Lambec. Within this space of us being mentored, we also incubated in the same factory space.
Okay, thank you. A comment from Dick. Great concept, but he also, I think, has a question. A question there. It's how many erections do you have in the coal industry?
Thank you, Dick. Yes, I would agree with you that it is a great concept. So we've done one or two installations in the coal industry, both of them being a rather small scale installations. We have over the years been very focused on the mining industry. A lot of it being gold mining was our biggest clients. However, when we adapt this technology to the coal industry, there's very little that changes depending on industry. The screens that we put on the coal sector are identical to the screens that you currently have there. The only difference would then obviously be the drive system of those screens.
Okay, thank you. Another question coming from Sam. Can a multi-slope or banana screen be replaced with these screens? What if the existing screen is a double deck?
Yes, thank you, Sam. So as I said now, the the screening application doesn't change. The screens are identical. They're exactly the same, whether it's a single deck, a double deck, a triple deck, or a multi-deck. The actual screening application and design doesn't change. It's just a matter of installing a different drive system. We have done a number of double decks, a number of banana screens, single decks. As I say, the only thing that changes is the actual drive system of the screen. Thank you.
Okay, another one from Karabo. What is the maximum feed top size the screen can handle?
Thanks, Karabo. There is no maximum feed size. One of the additional advantages, as I mentioned, is that with this drive system, we are not restricted in width and length dimensions. With traditional brute force equipment, you can only go so far away from your motors before you start losing your direction. Whereas with this equipment, the springs are responsible for the direction, and those are distributed across the entire length and width of the unit. So theoretically, we are not restricted in that by any means. I did in the presentation, there was the screen from the ceramic industry, which, like I said, does 100 millimeter separation, but the material coming onto it is larger than 600 millimeters. So that's on a 1.5 meter wide unit. If you have larger lump size or larger feed than that, then we can go with a 2.5 or a 3 meter wide unit. Thank you.
All right, I see your hand, Graham. Graham, okay. All right. Okay. Is there any more questions from the floor or comments? Okay, righty. I think it's it looks like we don't have any more questions or any comments, both from our chats, and I don't see any hands being raised at the moment. All right, Liz, Charles, and Zama, thank you very much for your informative presentation on your unit as well as its application. As a society, we will be posting a gift over to you guys, because obviously we couldn't meet you face to face. And again, I would like to thank all the attendees and hope to meet you again in our next technical meeting, which will be happening in September. So keep safe and enjoy the rest of the afternoon. Thank you very much.
Thank you. Thanks, Refilwe.
Thank you very much, and thank you for hosting us, and thank you to everybody for attending. Be well and go safe.
Yeah.